Of the Oxygen Concentrator Talk, brought to you by the Oxygen Alliance. My name is Mwawi Lungu, and I'm very pleased to be hosting the call today. Joining me are my colleagues Amaprit Rai and Timothy Mtonga, along with our technicians from Open02. On the technicians panel today, we have Francis Sambani joining us from Lilongwe, Malawi, Georgie Kwanga, Teto Sinjani, and Sharon Gozo, all joining us from Lilongwe, Malawi. So for those of you that may not be aware, the Concentrator Talk is a virtual meeting that the Oxygen Alliance hosts every Thursday from 2 to 3 p.m. Central African Time, where we discuss the different aspects of oxygen concentrator use, assessment, and maintenance. So if you have any questions, we encourage you to send them to us in advance so that we can have a look at them and provide you with the best answers. So you can do that through our email at info@oxygenalliance.org, and our technicians will do our best to help you with that. Just a reminder to everyone that we ask you to keep your microphones muted and your videos turned off, just so we conserve the bandwidth for everyone. So our topic of interest today, we'll be talking about troubleshooting and fixing problems on the control board. So be on the lookout for that. So as usual, I will read out the questions and we'll also paste them into the chat in case you didn't hear them clearly, so you can also get them from there. So we also have polls at the end of some of the questions, so please attend to them when they pop up. All right, so moving on to our questions for today. So our first question says, okay, I think I have just misplaced my questions.
While Maui is finding his questions, of course, with this being the Easter holiday week, I know we're all looking forward to some time off, and of course the religious ceremonies. But we do have fewer people, so we're, we can make this a little bit more of a fun and interactive session. So don't be shy to ask some questions or share your comments or feedback. I think we all know each other well enough in this group, at least. Maui, have I talked long enough for you to find your questions?
Yeah, great, thanks. I have found my questions, sorry for that. All right, so our first question says, I am a biomedical technician at a private clinic. I'm working on a DeVilbiss 515 concentrator, and I have refilled the sieve beds, but the concentrator I am working on has a faulty rotary valve. I don't have a new rotary valve, and purchasing a new one will take some time. But there are other 40 515 concentrators at our workshop, and I found a functional 515 valve block. Can I use it to fix the problem? So I'll ask Teto to take this one up.
Yeah, so thanks, Maui. So there are three types of valves that are found in a 515 DeVilbiss concentrator. The first one is the pneumatic valve, the other one is the rotary valve, and the other one is the four-way valve block. So as you could see in the image there, there's only like two types of the valves, because we tried searching for the other one, but we couldn't locate the image. So sorry for that. But the number one is the rotary valve. The other one is the pneumatic valve. Yes. So the pneumatic valve and the four-way valve are from old model DeVilbiss concentrators, and the rotary valve is more like the current one, and it is commonly found in the 525 and a newer model 515. So even though the valves are different in appearance, they share the same functionalities. So both valves tap power from the concentrator control board. So the difference between the four-way valve block and the rotary valve is their connection to the circuit board. So a rotary valve cannot connect. A rotary valve cannot be used on a board that is designed for the four-way valve, as well as the four-way valve cannot be connected to the board with the rotary valve connection. So even in the graphics there, you can see that the boards, they look like the same, but they're different. So the one on the left is the one that is meant for the four-way valve, and it actually has like 4-pin connector as compared to the one on the left that is designed for the rotary valve, because the motor has like multiple wires, including for the sensor itself. So to answer the question, yes, you can use the four-way valve, but you need to find a functional board that is meant for the four-way valve. And you can easily identify them by their Auxin sensor glass tube. So the board that is used for four-way valve has a longer like glass tube, the Auxin sensor itself, as you can see on the right side, other than the board that uses the rotary valve that has like a shorter Auxin sensor. Yeah, so they might actually also have, they also actually have like different part numbers. Yeah, thanks, Maui.
Thank you very much, Tedo, for that explanation. So I don't know if we have any questions from the audience. As Amaprit said, we can make this as interactive as much as possible, since there are a few of us. So if we have any questions, you are welcome to raise your hand or just unmute your mic, and then you can ask the question. So we have a poll at the end of this question. So Amaprit, if you would please launch that one up.
Indeed,
Tedo, I see you have a hand.
Yes. Tedo, do you, before I launch the poll, did you want to add on?
Yeah, I just wanted to add up something. So in terms of like having the board itself that that can go on the four-way valve, it can fit in the 515 Devo Beast old model because the flame is still the same. So you can still mount the board together with the valve block. Yeah, thanks.
Thank you, Tedo. I am launching the first poll. And our question is, do you have easy access to new concentrator components like rotary valves, filters, PCBs at your workplace? And Moawi, do you want to just remind everyone where to access the polls?
Yes, so if you are joining us from your mobile phone, just go to the bottom right of your screen and hit on the menus option, and then a window will open up, and you will see the activities menu as one of the options listed in the menu that pops up. And if you click on the activities menu, you should be able to see the pause option from there. If you are connected through a computer, then you also go to the bottom right of your screen, and the activities button is the last icon on the far right. So you click on that and you should be able to access the pause menu. Thanks.
Thank you, Moawi. So our results have come in. It is very 50-50. So I just want to take a second here before we move on to remind everyone that part of what we're trying to support you all with the Auxin Alliance is having access to concentrator components. So do feel free to reach out to us through our email or through the Concentrators Talk sessions that we have, and let us know if you need parts that you cannot find easily within your markets. Thanks, Maui.
Thank you very much, Amapri. So now moving on with our questions. So the next question says, I am a technician at a certain hospital. I was working on an ASAP intensity concentrator from a Gloucestervent anesthesia machine. The concentrator was producing low purity of oxygen and the compressor was squeaking. I serviced the compressor and replaced the sieve beds. I was able to achieve 90% purity at 8 liters per minute. Then I replaced the oxygen concentrator on the anesthesia machine and returned it to the theater. But the anesthetist has reported that the concentrator LED for low purity is on, meaning to say that the concentrator is now producing low purity, even though I tested it for 2 hours and the purity did not drop. What could be the problem and how can I resolve it? So I will ask Francis to take this one up.
Thank you, Mara. So the Grosser vent helix is a low-flow draw-over anesthetics machine. The Auxin concentrator on the Grosser vent is one of the components, one of the main components on the Grosser vent anesthesia machine, and it is used for two main purposes, one being to provide oxygen and medical air to the patient to breathe, and also oxygen to drive the ventilator. On our left, we have a view of how the Grosser vent helix machine looks like. So it has four main components. The first one already mentioned being the oxygen concentrator that we can see. And also we can see just on the bottom of the shelf. And then on the right of the same picture, on the right of the picture, we can see we have a helix ventilator. So that's also one main component. And then we have the vaporizer. That's also the third component. And behind this whole thing, we have the UPS, the uninterrupted power supply. So those are the four main components of the ventilator. So the compressor used with this concentrator has two outputs. The first one goes to the sieve beds, whilst the other one goes to the goes out to be regulated and is given out as medical air, which is also filtered. And the picture on the right in our graphics, we can see that we have the compressor. So that is like the inside, the schematic of this concentrator inside it. So you have the compressor, and then the compressor has a connection where it divides the air. The other part of the air goes to be filtered out and regulated, and will be given out as medical air, and the other is shared to the sieve beds, and that will give out higher oxygen-rich air. So the anesthesia machine has flow meters for medical air and oxygen. When one fully opens both flow meters for air and oxygen on the anesthesia machine, they will not be able to achieve the maximum purity they can achieve if they had the flow meter for air fully closed. This is so because when the flow meter for air is open, one limits the amount of air going to the sieve bed, which leads to less pressure build up in the sieve beds and eventually low purity of oxygen. This should explain why the oxygen concentrator was producing low purity, even though it was fixed and was left to be okay. So when used on a patient, usually 2 liters per minute of oxygen is sufficient to provide 50% of oxygen in a patient breathing 6 liters per minute. What this means is that you have 2 liters of oxygen and 4 liters of air, medical air, being given to the patient, and roughly you get around 50% of oxygen using this 1:2 ratio. So a trained anesthetist can increase the oxygen flow if higher levels of oxygen saturation are required. The anesthetist should know the amount of oxygen needed for a patient and the flows for air and oxygen to be blended. If he sees that more oxygen is needed for the patient, let's say maybe greater than 82%, then I recommend a separate source of medical air be provided for such a procedure. So just make sure that the separate source of air is filtered as well as regulated to the recommended pressure before being delivered to the patient or before being blended in with the oxygen. Thank you.
Thank you very much, Francis, for that explanation. So if we have any questions or comments from the audience, you are free to ask, and then Francis will give you the right answers. So we also have another poll at the end of these questions. So as we are waiting for the questions, Amopri, if you would launch that one up.
I will. We actually have 2 polls with this question. Our first poll that I've just launched is, are you familiar with a Glostavent anesthetic machine? I personally am not familiar with this machine, actually. I am familiar with the components, some of them, but I have not come across this one myself. And it looks like we are quite split on this, with 50-50 on the votes. And our next poll question that is related to this is, have you ever fixed a concentrator from Glostavent before? And I think if I was looking at that graphic, that concentrator that's used in the Glostavent, I think is common in some other types of anesthesia machines. Francis, correct me if I'm wrong, but is that the Diamedica concentrator?
Yes, so that's the Diamedica concentrator, and mostly they use the AirSep model. So the earlier versions had the 8-liter AirSep, and the newer ones have the 10-liter AirSep on them. So I think they use the AirSep because of the pressures, and the AirSep gives out the graded air at 20 psi. So you have like high pressure, unlike if it was a Devovis, which uses 8.5 psi, I think.
George, you also have something to add on?
Yeah, just want to say that, yeah, I've seen some Glostavent anesthesia machine that uses Devovis 515.
Got it. Yeah, I mean, I think you need the higher flows, right? With the anesthesia machines.
Unfortunately, this one it's for low flow. It's not for the higher flow.
Okay, got it. Yeah, I think the 10-liter DeVilbiss units are also 20 psi, so that would make sense to me. Yes.
Go ahead, MT.
Yeah, sure. So I was actually thinking about it, George, that maybe the one you saw that had a Devilbeast 515, maybe the Glostavent itself came with an AirSep, but maybe they improvised. So maybe it might be that.
I don't know, but the way it's designed, I don't think it can be modified in the field, because usually the Diamedica people buy this concentrator and do the modification themselves.
I see.
Very interesting. So the poll feedback is 50-50 on this one as well. So it seems like there are some of these floating around our markets.
Okay. So we can proceed, right?
Please.
All right. So moving on with our questions. Our next question says, I replaced the transformer on a Perfecto 2 oxygen concentrator, and the concentrator was back to normal. It was then sent to the ward, and 3 days later, I received a phone call from the nurse complaining that nothing was turning on when the power switch was flipped to the on position, apart from hearing the sound of something running inside the concentrator. When I went to check, I found that only the fan was running while all the other components, including the LED, were off. What could be the cause of this problem? So I will ask Sharon to take this one up.
Thank you, Mari. Okay, so in this model, this problem arises when there's a problem with either the transformer or the circuit board. So this can be due to these components being faulty or just a problem with the electrical connections. So the fan works even when the transformer or the circuit board is faulty, because it gets its power directly from the power source. So firstly, check if all connections of the transformer and the circuit board are well secured. If they are secured, then you have to check for continuity on of the cables and traces with a multimeter. So you need to make sure you resolve any disconnection you have identified so far. So if all cables are well secured and there's no discontinuity, check if there is voltage across the input and output terminals of the transformer. If the output voltage is not within the recommended range, then the transformer is faulty and you have to replace it. If you find that the transformer is fine, then proceed to check the circuit board. So check if the board is receiving the required voltage. If you find that the required voltage is reaching the board, then you need to check on the board if there's any visible damage to the components. You also have to test the other components. It is possible to have some damage to the components without seeing them. So after reaching this far and the problem persists, then if a similar board is available, try replacing the board. If the system works with the other board, then the board is faulty and there's need of a replacement or just a replacement of the components that are damaged on the board. Thank you.
Thank you very much, Sharon, for that explanation. If we have any comments from the other technicians or some questions from the audience, you are free to ask them. Right, seems we do not have any questions here. So moving on with our questions, the next question says, I have an ASAP intensity 10 oxygen concentrator that I am working on. The relief valve pops when the cycle switches to the left sieve bed, of which I suggest that the solenoid for feeding this sieve bed might be damaged. I have scavenged a valve block of the same model from my concentrator graveyard, but I am not sure which of the 4 valves is working or damaged. Can I test the integrity of the valves? So I will ask Francis to take this one up.
Thank you, Mara. So, a solenoid valve is an electrically controlled valve which features an electric coil with a movable ferromagnetic plunger in its position. In the right position, the plunger closes off a small orifice, passing an electric current through the coil, creates a magnetic field. The magnetic field exerts an upward force on the plunger, opening the orifice. This is the basic principle that is used to open and close the solenoid valve. So, yeah, as we can see in our graphics, we have an orifice. Basically, we have the plunger, which is number 7, and then we have the small orifice, which is number 9, and we have the core windings, which is number 5. So if you have current passing through the core windings, they'll magnetize the plunger, pulling it up, opening the orifice for air to pass through. So that's the basic working principle of a solenoid valve. When the coil is damaged, current will not be able to pass through the coil, and the plunger cannot be magnetized. The coil itself has a resistance, and the resistance is specific for each solenoid valve depending on the number of turns of the wire in the coil. This is to mean that different solenoid valves for different Auxin concentrators will have different coil resistance. So that's to say that the ASAP, the valves for the ASAP will have different resistors. Even the valves in the ASAP themselves will also have different resistances. That is for the feed, the waste valves, and also compared to the equalizer valve. So even these valves in the ASAP compared to the Vobis 515, the older models which had the solenoid valve, they also have a different core resistors themselves. So the ASAP intensity 10 uses 5 two-way solenoid valves, 2 for feed, 2 for waste, and 1 for equalization. An ohmmeter can be used to determine the condition of the valve coil. When using an ohmmeter in the new life intensity 10, valve coil readings should be will be indicated on the flow meter. So next slide, please. Yeah, thank you. So for the ASAP intensity 10, in 120 units, 120 VSC units, you have 1000 ohms for the equalizer valve, and the feed and waste valves coils will measure 850 ohms. And as for the 220 or 240 VSC units, you have the EQ coil with has a resistance of 4300 ohms, and the feed and waste coils have a resistance of 3100 ohms. So if you measure the resistance of the coils and find a lower resistance or no resistance than specified, it means that the valve is damaged and needs replacement. You can also, so this is one way of determining if a coil is damaged or not, if a valve is damaged or not. But then you can also determine which coil is not opening or operating by checking each valve to see if it becomes energized or magnetized during unit operation. To check for coil operation, you have to follow a couple of steps, and one will be to remove a plastic cap securing the valve coil to the valve stem. So as you can see, you have the valve stem in the middle. That is on solenoid valve number 3, written number 3, a small 3 on the top right corner. So you have a coil stem, and it has the lid open, the red lid open, like removed on top of it. So you don't need to necessarily remove the coil, but then you just have to remove the top lid. So that's the first step. And if you remove the lid, with the unit operating now, you should hold a paper clip or a metal tip of a screwdriver slightly over the top of the valve stem, located in the center of the coil. So the valve stem, as we already said, is the one in the circle, so in the center, sorry. So you just need to hold a screwdriver over it. So when the coil becomes energized or magnetized, the paper clip or tip of the screwdriver will be put down onto the valve stem, indicating that the valve coil is operating. If the coil is 40, it will not be energized, and that will require replacement. So those are the two ways on how you can check if a solenoid valve is working or not. And for the ASAP, this is how you can check it, as in the second one. I don't think the second method applies to other valves. So you're better off using the ohmmeter in that case. Thank you.
Thank you very much, Francis, for that explanation. So if we have any questions from the audience, you are free to ask, or if we have any further comments from the other technicians, you are also free to ask. Yes, Mteto, you have a hand.
Yeah, so I think it's also important just to say it out that these solenoid valves, they look physically the same, like for the 120 concentrator and the 220 volts concentrator. Correct me if I'm wrong, Francis. So I think the important thing is just testing the resistance itself and then follow the other steps. Yeah.
Okay, great. So we have another poll at the end of this question. So Amapri, if you would please launch that one up.
Yes, the poll is, do you measure the integrity of a solenoid valve before replacing it? And we'll give everyone a few seconds to answer. And it seems like we've got a lot of yeses here. So it seems like most people do indeed measure the integrity before they put the solenoid valve in. So that's great.
Okay, great. So moving on with our questions now. So the next question says, I am a biomedical engineer at the district hospital, and we are making preparations for corrective maintenance on concentrators which have stopped working or are malfunctioning. The activity will be carried out next week, and during the maintenance, besides servicing the compressors, some of the concentrators require that their sieve beds be refilled with new zeolite. I would like to refill the empty sieve beds in advance in preparation for this activity, but I am not sure of how properly I can store the refilled sieve beds without having to damage the zeolite. And this is my first time refilling the zeolite before the actual maintenance time. How best can I store the refilled sieve beds? So I will ask Mteto to take this one up.
All right. Thank you, Maui. So moisture is one of the factors that causes the degradation of zeolite. As such, the process of refilling sieve beds should be done in a low humidity environment. So it is important to always like have a humidifier, a humidity sensor whenever you want to refill sieve beds to monitor the humidity levels. So if the humidity levels are high, you can use a dehumidifier to help in reducing the humidity. So you need to ensure that the humidity is below 45% before you begin refilling the sieve beds. So in this situation, when you have refilled the sieve beds under the conditions that I've just stated, like below 45% in terms of humidity, you need to make sure that you seal the fitting on both ends of all the sieve beds with end caps. So sometimes you might not have end caps, so you could use seal tape, wrap it in a good way so that the zeolite is not exposed to air. So sometimes you, like in this case, you might find that you are not putting the sieve beds on the same day, maybe the following day. So in case of storage, I would recommend that you do not place the sieve beds on the floor, as they may expose, as it may be exposed to moisture. So instead, you can keep the sieve beds in a cardboard box until the following day or until they are ready for use. Yeah, thanks, Maui.
Thank you very much, Tato, for that explanation. So if we have any questions from the audience, you are free to ask, or if you have some comments from the other technicians, you're also free to add on to the explanation that Tato has just given us. So,
Sorry.
yes, go ahead.
I was supposed to raise it. So just to add on, maybe people might be wondering like how are they going to get the humidity sensor? So I would advise them that if you have like an Arduino kit, that can also work. There's like a DT, I think it's known as a DHT11 sensor, and you can connect that to an Arduino, and then you can literally measure the humidity inside the room. Yeah.
Okay, great. Maybe one day one of our topic of interest should be how to make that one.
Yeah, sure, we can do that.
All right, so we have another poll at the end of this question. So Amaprit, if you please launch that one up.
Yes, this poll is, have you ever refilled sieve beds before? And while people are answering that poll question, I am happy to share that I am right now in Kolkata in India, which is on the Bay of Bengal. And today, with the humidity in the air, it felt like it was 50 degrees Celsius. So sometimes you don't need to measure the humidity in a room. You can just feel it.
Okay, great. So did you happen to check with the weather app maybe just to see like at what percentage it was?
I did, yeah. So it was 90% relative humidity. That's right on the ocean.
Wow. Yeah, that was very high.
Very high humidity. So definitely if we are repairing sieve beds here or refilling them, we want to be extra careful to do it in a humidity controlled environment. And it does seem like most people have refilled sieve beds before. So I'm glad that we are talking about humidity today.
Hey, great. Right, so we'll take a slight diversion as we normally do from our questions, and we'll now jump on to the topic of interest. So as I mentioned at the beginning, today we'll be talking about troubleshooting and fixing problems that are having to do with the control board. So George is going to take us through that explanation. George.
Thank you, Maui. A circuit board, this is a component within the concentrator. The circuit board is like a heart for human beings, or like a processor for a computer. So as we all know, a concentrator uses a pressure swing adsorption process to produce Auxin. So with this process to be achieved, there's a need of a circuit board to control the opening and closing of the valve on Auxin concentrator. So depending on the mode of the concentrator, the circuit board is also responsible for monitoring the pressure in the system. It is also responsible for alarm systems. And most important, it is also responsible for Auxin purity monitoring. So as you can see in the graphic, that's one of example of a circuit board. That's for an air-safe concentrator. So with air-safe concentrators, they have gone through several iterations on the design of their circuit board, moving from the whole components to surface mount components. These allow for higher density and cheap assembly, and also moving from using MOSFET transistors to IGBT transistors, that is to achieve high efficiency. So as you can see in the graphics on the top left, that's one of the design of air-safe concentrator circuit board. On the right, top right, that's another type. So that's a front and the back of the circuit board. Down there, you can also see there's another circuit board that's for the same air-safe. And on the right down picture, that's another design for the circuit board. So basically in this graphics, you can see we have 4 types of circuit board, but all of them are for air-safe. So how they work as you can see in the graphics, some circuit boards have LED, some do not have the LEDs. So for circuit boards with LED, some have on the board there's the labeled where you have EQ, that's equalizer, that's in correspondence to the sound valve for focalization. And there's the LF, that's left feed, that's for a sound valve for left feeding. And there's RF, that's right feeding, and that's sound valve for right feeding, and right waste for right waste. So all these label you can see from the PCB. So the way they operate, you need to observe the LED sequencing. So 2 green LEDs should be turned on at a time. In the case of models that do not have LEDs, you observe the sound of the relief valve on the compressor. So if it's popping, you know that the circuit board might have issues. The relief valve may not pop just because of the circuit board, but it's one of the reasons that you may have the relief valve popping. So that's how you can troubleshoot with circuit board that do not have the LEDs. But for those LEDs, you need to observe the sequencing of LEDs. You can also test the voltage across the solenoid valve. That is mostly for those boards that do not have the LEDs. Even those that have the LEDs can still check the voltage across the solenoid valve. So with 230 volts models, the voltage across the solenoid valve is supposed to be 200 volts DC. While with 110 volts models, the voltage that you're supposed to get it's around 100 volts DC. So some of the common failures that we have come across with this circuit board for air-safe mainly is to do with the damaged resistors. As you can see in the graphics, where it's indicating the resistor. We also have issues with the varistor and issues with the capacitor. Basically, this is due to voltage fluctuation because that is on the power supply input. So you you supply say 230 volts or 110 volts on that side. So that power goes through the varistor, the resistor, even the capacitor. So when you have power fluctuations, these components get affected most often. So the solution is that these components are easy to replace. You can get them from electronics shops, and they're easy to replace by just soldering. Another circuit board that I would like us to talk about is for developers. Next slide. For developers, concentrator circuit board. As you can see in the graphics, we have that's for 515. That's the circuit board for developers Auxin concentrator. So the way it operates, it's as other concentrators, it's on timed cycle. So the cycle is controlled by the circuit board. So this circuit board controls the timing, how to open and closes the valve. So the board will send the voltage to the valve, causing it to shift to one safe bed and next to the other safe bed, and that's how it operates. So this board is also responsible for controlling the electronics alert system, that is the alarm system. So some of the common problems that we have faced with this type of circuit board mainly is damage to the fuse, and you can see in the graphics there, usually you have issues with that fuse, so you just have to get another fuse and replace that one. And in some cases, the transformer get damaged. So what you need to do is you can get it from the electronics shop, but if it's not available, I think you can also scavenge from other circuit boards. Next slide. Another board is for Respironics Everflow concentrator circuit board. In this, you can also see there's a fuse, and this can also be replaced. You can also get it from electronics shops, and you can place. Another component is the transformer that get damaged most often. These are easy to replace. You can just remove them by soldering and replace them with a new one from a electronics shop, or you can even get it from another old concentrator that is not working. Just an advice, you don't need to, there are some cases, some people, they can jump the fuses. This can damage your circuit board permanently. So you need not to do that. So the best thing to do is to replace the bent components. Thank you so much.
Thank you, George, for that very detailed explanation. Does anyone have any questions or comments? I think Malawi is just having a few connection issues. Mteto, please.
Yeah. So unfortunately, I think you just stopped sharing the slide. I wanted to point out on the Respironics, just closer to the transformer, there is also like a round fuse. That one, I think I've come across it. It also gets bent more often. It's red in color, close to the. So there's an oval component. It's known as the varistor there. Yeah. So there's the one that is round, the circle one there. Yes, that one. I think that's the fuse, if I'm not wrong, isn't it, Maui?
Yeah,
Come
that's
again, I just lost you for a minute there.
Yeah, I was saying that on the Respironics, closer to the transformer there, the round one, the one in red, close to the varistor, I think it's a fuse, right? Is it the one that also gets damaged more often? I think.
Yeah, that's the fuse, and normally that's the one that gets bent.
Yeah, sure. I just wanted to add that, Amapri.
Thank you, Mteto. Malawi, now that you are back, do you want to ask our next question?
Yes, please. Okay, so our next question says, I was working on a DeVilbiss 515 that was brought to the workshop yesterday. When I switched it on, it started running, then I heard the compressor stop. Then it started again after a few seconds, and then the service alarm came on and the concentrator shut down. What could be the possible cause and solution of this problem? So I will ask Sharon to take this one up.
Thank you, Maui. So a DeVilbiss Auxin concentrator uses a double head air-free compressor that takes in ambient air from the surrounding and compresses the air to increase its pressure. So to answer your question, you should be aware that every compressor has its own voltage ratings. So in places with unstable power grids, sometimes the compressor in the concentrator might be receiving lower voltage than the rated voltage. So this can be the cause of the malfunctioning of the compressor. So firstly, you have to test the voltage input from the power source to make sure you're getting the appropriate stable voltage using a multimeter. This voltage can be checked at the compressor connector using a voltmeter. If the compressor is receiving enough voltage, then the run capacitor that is connected to the compressor could be defective. So a defective capacitor can result in jamming the compressor or not starting the compressor at all. So replace the capacitor and see if this resolves the problem. So please take note that when replacing the capacitor, it should have the same voltage rating and capacitors rating as the previous capacitor that you have removed. If a capacitor of a higher capacitors than that of the compressor is used, it results in heating up the compressor. On the other hand, if a capacitor with lower capacitors is used, the compressor will not be able to start. So take note also that you should not touch or allow metal objects to come into contact with the terminals on the capacitor, since a capacitor may be charged. Thank you.
Thank you very much, Sharon, for that explanation. So if we have any questions or comments from the audience or the other technicians, you are free to add on to what Sharon has just presented to us. So we also happen to have another poll at the end of this question. So Amapri, if you would please launch that one up.
Yes. So this poll is, have you ever replaced the capacitor of a concentrator before? And we'll give it a few seconds for everyone to answer. And it looks like we are getting pretty much all yeses, except for one vote. No, now more than just one vote on no. All right, it seems like all the votes are in. Most people have, but not everyone.
Okay. Right, so now moving on to our final question of the day. So the question says, I am a biomedical engineer at Riverside Hospital. When I was refilling zeolite in the sievebed, I discovered that the O-ring for the top cover had some small cuts as shown in the image. We had no spare O-ring in our stores, hence I had to use the same O-ring. The oxygen concentrator was performing well after the service. Should I recommend the use of this concentrator? So I will ask Francis to take this one up.
I think his microphone is muted.
Yeah, I'm sorry, I had my microphone muted. All right, so as for the O-ring, you can see in the graphics, and they have two areas with the arrows pointing at them. showing the areas where some material on the O-ring has been eaten out. So you're advised to add a little amount of plumber's wet tape around the O-ring. That will help your O-ring to withstand the operating seatbed pressure for a longer time than using it in that state. One of the important things to do after refilling a seatbed is to do pressure test. So different Auxin concentrators have different pressures at which they operate on. So make sure that the pressure, you use the required standard pressure when you're testing the pressure on the seatbed. And so if the seatbeds are able to withstand this set pressure with no leakages on the seatbed, the Auxin concentrator is ready to be put on an extensive test and deployed if it passes the test. So normally you deploy it maybe above 87% just to make sure that it runs on for a longer time. So thank you.
Thank you very much, Francis, for that explanation. So if we have some questions and comments from the audience or the other technicians, please add on before we end our session today. Oh, and we also have another poll at the end of this question. So Amapri, maybe you just want to launch that one up.
Yes. So our last poll of the day is, have you ever done sieve bed pressure testing? And while we're answering, I am happy to share that I, as someone who is not a technician, I have actually done this before. We built a independent gauge for one of our concentrators to be able to do the pressure testing. And it was a very interesting process. And I think most of our votes have come in, and this one is fairly split. It's 50-50.
Okay, great. All right, so reaching this far, this now brings us to the end of our concentrator talk today. And I would like to take this opportunity to thank you all for joining us for today's call. I know the attendance wasn't as good, but still it went on well. So please remember that we'll also be meeting again here next week, same time, and we'll be having our special session this week. So maybe Amapri, you would want to just talk about that one.
Yes. So next week on the 21st will be our special session by Ms. Debbie Aloyo. She will be talking about some best practices for biomedical teams in terms of clinician management and how to talk with hospitals to get maintenance budgets and contracts, and how they've had success doing this in different countries in Africa. So I am very excited to hear her talk. I think it will be useful for all of us, especially as we try and build a sustainable environment around maintenance. So I hope you are all able to join us after, obviously, the Easter holiday weekend.
Okay, great. So just another quick reminder, we have a website. So if you want to know more about the Oxygen Alliance, please visit our website. We also have a YouTube channel where we post all the recorded sessions of our concentrator talk. So please visit it, and don't forget to subscribe once you get there. So until next week, I would like to wish you all a very great weekend. Bye.
Thanks, everyone. Happy Easter. Bye-bye.
Bye.
Bye.
Bye.